Hi, I'm Tom Stevenson, and welcome to our Lecture 1 of the Residential Construction course. Hopefully by now you've had a chance to look at the course outline overview, so if you haven't, I would make sure that you look at that video. And we're going to be starting off with our first lecture, where we're going to be breaking it up into two sections, Lecture 1A and 1B, I'll call it. And in the first section, we're going to be looking at site plan, sort of where you want to lay out the building, some of those aspects of selecting a lot, and where this house is going to be built. As we move through the course, we'll be kind of starting from the beginning. So the site is probably the first one where you purchase a property, and you kind of do that in combination with zoning and permit processes, and what can I build on this lot. And it kind of falls back to what we call highest and best use. You know, what is the highest and best use for this property? Developers are always looking at that and trying to answer that question. If I buy this property, what can I do to it to get the most value out of it, right? And the city or municipality, they have limitations on what you can and can't do. You can change things, as you'll see, but that requires a lot of time and effort, and maybe you can't change it. So it depends on the lot, the location, the municipality. There's NIMBYism, not in my backyard. All of these elements kind of converging together to say yes or no. So these are some of the things or trials and tribulations that builders and developers and clients and homeowners have to grapple with. So we're going to be referring to Chapter 5 of the Understanding Construction Drawings textbook today. And we'll be pretty much following the chapters from this section forward. Hopefully you've had a chance to read Chapter 1 in the book as well. And we'll refer back to a few points in the other chapters, 2, 3, and 4, but we're really going to be focusing in on how the house is constructed in this particular course. The other supplemental book that we'll be using, which you can download for free online, is the Canadian Wood Frame House Construction book, which is quite a good book. It gives sort of an overall reference to wood frame construction in Canada. So we'll be going through chapters 1 and 2 of that. They kind of correspond. So as you can see from the screen here, these are the areas that we'll be looking at. So in 1A, lecture 1A, which I think will be around 40 minutes or so, we will be looking at surveys, site plans, that sort of process. And in 1B, which will be similar, we'll be looking at the permit process and zoning and inspections and those scenarios that go on when we're actually trying to determine what we can build. So some of the things that you'll find on a site plan are setbacks, you know, the location of where the building is going to go from the property. And so to have that, we actually have to have a survey of the property. And so the survey is the legal description and layout of the property that the purchaser has bought. And it sort of describes the width, the length, the angles, the elevations, topography of the particular property. And within that, zoning will sort of dictate, well, how much can we set back the building or the house from the property lines. And you just can't build a house anywhere you want. You have to fit within the parameters that is provided by the municipality, town, or city that is the jurisdiction where you're attempting to build. So you'll find all that type of information on a site plan. And of course, grade heights, that's elevations of the property. And we also have to be able to determine, reference to that, how deep do we excavate to put our footings in and our foundation walls? So this stuff comes together, and we'll talk about that in other chapters too when we talk about the substructure and anything below grade, the foundations. So the depth, what is the depth for the footings? And the footings are what the walls of the foundation rest on, and they help to distribute the load of the house, the weight of the house, into the ground and ensure that the ground can support that weight. Because obviously, if it doesn't, then the house is going to shift, and then you've got a myriad of problems and issues that will be going on. So we also have a bunch of infrastructure things that we need to deal with too. Where are the sewers located on the street? Where is the feeds for the electrical lines, for the water supply to the actual house? Because we're not living off grid typically in any kind of town or municipality. There are some houses that are off grid, which means they're not connected to the utilities, they're not connected to a drainage system. They have to be able to cope and create all of these things on their particular site. But in most municipalities, towns, and jurisdictions, you are connected up to a grid and infrastructure. So we will be looking at that, and of course in the other lecture 1B we'll be getting into the zoning requirements and permit requirements, and then how does that fit in with the survey and site plans that we're going to be discussing now. So site plans, usually we will call it a site plan if it's for one particular house or one building. This is the site plan. We will use the term typically a plat plan if it's a subdivision where we're doing production home building. We're building maybe 100 houses or 1,000 houses. Well, the overall plan for that would be a plat plan, because now you got to coordinate between all of the houses that are being built. The grading has to be done for the streets. We have to ensure that the runoff from storms is going to be able to run in the right direction, that the sewers are going to be able to have the capacity to carry that water. We may have to have drainage collection areas for if there's really bad storms, until the sewer system can catch up, that it's like an overflow. So all of this has to be worked out. So we call an individual plan a site plan. We call, when it's a multitude of lots, a plat plan. You may also hear the term plot plan used. It's typically more of an American term. I see it used out west as well. Site plan, plot plan, they mean the same thing. All right, so it's just that individual property, and what are the parameters around that property, and what are we going to build on it, where are the setbacks going to be, and what are some of the restrictions that are involved with that. So each individual lot will have a site plan if it's part of a new subdivision. So each particular lot or building or condominium will have its own site plan if it's part of a bigger area. You might have a plat plan for a series of condominiums that's going in a huge field that might be empty right now, and they're going to build it in phases, and each condominium is going to have its own legal description. So you might have an overall plat plan of how everything works together, but then you'd have individual site plans and surveys, legal descriptions for those particular properties, because the condominium corporation would have jurisdiction over those particular properties. So it really, the plat plan is where a builder or a developer, they buy a property, and as I mentioned, they're looking for highest and best use. How can we best use this particular property? What can we maximize? What will the local jurisdiction allow us to do? Local jurisdictions will have a 5-year, a 10-year, a 20-year plan of how they see this area being developed. And so this plan that they have, master plan that they have for the particular area, that's what they want to place on it. So they might have a certain density, how much units are we going to fit? What is the capacity here? And very often municipalities, they want to increase density. They don't want to have everything so sprawling on big, large lots, because that means more infrastructure requirements for them. It's more taxing on them, taxing literally, and on the individuals. As well, from a climate change perspective, you are spreading your infrastructure longer. It's consuming more resources. It's not as energy efficient either. So those sort of areas sort of work together to try to satisfy that particular master plan for the area. And different municipalities will have different names for it. They may call it the draft plan the builder submits for that particular area in that plat plan. If they can't really sell any units until they have draft plan approval from the municipality. So that's the aspect of the development of that area. And of course, if you do get that approval, you're going to subdivide the lots from that overall lot that maybe the builder purchased from a farmer or something of that nature. And it's going to be subdivided, and there's going to be a legal description for each lot so that they can sell each lot separately. So, this is kind of a key map that you may find on a larger drawing, and the key map sort of shows within the subdivision where the houses. So each one of those little tiny dots there is actually a lot. So that would be a building lot, each one of those, right? And we've got a couple that I think I show in these slides, which is pointing to this little area in here. And this whole subdivision could have been built in phases. So they'd have different phases for the different areas that were built out. They don't build all 1,000 houses at once. They'll build a section of houses and they get finished, and they'll have different closing dates. And so when you start a house, if you had them all start at the same time and all finish at the same time, take a huge amount of resources and money. What you do is you design it so that you've got houses being built, and then the resources, say the excavation crews, they might be doing excavating 7 houses in 1 week. Then the next week they go and excavate another 7, and they excavate another 7 after that. So it's sort of this linear scheduling or line of balance scheduling that takes place. Same thing then when they finish the 7 houses in 1 week, they go to the next 7 houses. Then you might have the forming crews come in to lay out the foundations for those 7 houses and pour the foundations and have them inspected in the next week. And then they will go on to the next 7 houses. And it sort of flows along like that. And then they break that work up into phases, and then they try to pre-sell that section of houses, and they'll have a predetermined closing date based on the time period that they expect to build those houses. I think in the book, the CMHC book, it says 16 weeks to build a house. It's a little bit ambitious. I would say that a lot of builders, they work on like around 140-day schedule, 150-day schedule, 160-day schedule along those terms. And that's just to build the house. I'm assuming then at that point, and when you look at the CMHC text on that, the infrastructure would have been in, the sewers and the drains, and the hydro would have been all roughed in, because that takes a lot of time to put that infrastructure in. But to actually build the house, a new subdivision house, you're probably looking at a time frame of around 140 to 170 days, depending on the square footage of the house and the type of houses that is going in. And depending on the jurisdiction too. It can be done faster. Certainly it can be done faster, but typically with availability of resources and that sort of thing, it's kind of in that zone. While it can be done faster, certainly, if you want to spend a year planning and executing and prefabbing a house outside, it can probably be built within a week if you want to. But to do it efficiently, and typically it's usually in that time frame. A custom home is different. A custom home takes longer. There's more decisions to be made. You don't have the same kind of control over your resources. So a custom home might take anywhere from 8 months to 14 months with a typical time period of probably 11 to 12 months. But again, things can be done differently depending on the need and the push by the client and the costs. So grading plans are designed out of the legal descriptions from the plat plans, and overall, this has to be designed from a perspective of how is the water going to run off if we have storms. And they typically will base this on a 100-year storm. So what's the worst storm we've had in the last 100 years? And will the water effectively run off? And they usually add a factor of safety to that as well, so it's not just at that level. And they design the slopes and the drainage based on the existing topography, because you can't really totally change well, you can, but it's very expensive to. but the existing topography and how to take advantage of the existing slopes and natural curvature of the Earth's surface and regrade it and adjust it so that within the streetscape and the layout of the roads that there's the capacity that the water will run away from the houses. You don't want running to the houses, so you always want it to slope away from the houses where possible, and will slope towards the drains that are put in, or will slope towards maybe a natural, like a creek that runs through the property, where you can take advantage of what was being taken advantage of before the houses were built. But for sure, you want to make sure that you don't build these houses here and all of a sudden it starts flooding out the houses across the street or in an existing neighborhood. So you want to make sure that it's safe, that there's going to be no areas that go underwater during a major rainstorm that could potentially cause loss of life, etc. So it has to be really well designed that way. Now, we're living in a time where we have a lot of climate change going on. Sustainability is a big issue. And things are a little bit more unpredictable than they've been in the past. Not that they've ever been that predictable, but within a certain parameter and risk levels, it's been reasonable. And we do have some issues. I think New York City's had 3 100-year storms in the last 10 years. You got to ask, if it's had 3 100-year storms in the last 10 years, then obviously whatever we've been looking at is out of date, or we've got to make some adjustments to how we calculate things, because that means that we're running beyond what we designed things to be, and we're running into a lot of damage and potential for loss of life, etc. So we have to be very cognizant of that, and building departments and the Model Code of Canada, the National Building Code, is looking at means and ways that those adjustments have to be made. I should mention that both the books that you're using in this course, they really sort of reference the National Building Code. I'll be giving adjustments to focus on the Ontario Building Code. You'll be doing courses in your programs that are specific to the Ontario Building Code, or if you're taking it from somewhere else, that particular code. What you should know is if you start to know how a building code works, like the National Building Code, it's not a big stretch to move from National Building Code to the Ontario Building Code, or from the Ontario Building Code to the National Building Code. That's not that difficult. So there's these little iterations that go on with that. But for sure, whatever province you're working out of, that's the building code that will have jurisdiction over that. Some provinces are small enough they don't have their own building code, so they just use the National Building Code. Provinces like Alberta, British Columbia, Ontario, they have their own building code, but it's really built from the National Building Code. Like you look at certain sections, they have the same reference numbers, but they may have different code requirements. For example, Ontario tends to be pretty progressive when it comes to energy efficiency, whereas Alberta might not be as effective that way, or maybe they may be more effective that way if they're making changes. So grading plans, the engineers will adopt and design that grading plan so that the water will run off, and as I was mentioning, under the severest conditions, and then that will show that runoff. They would have it for the whole plat plan. This is just a snapshot. I wouldn't be able to fit the whole plat plan on this screen, but this is actually just this corner here is actually in reference to that corner right there. So you're looking at that street right there in this corner section here. And that would be referencing the plat plan and the plat plan for the drainage of the actual site. And this is individual lots. So each person that buys a house or family that buys a house would be buying one of those lots. So then there's going to be an individual site plan for each lot. And when you buy a property, you buy, the survey will come with the property, which provides you the legal description for the property. It's from that legal description of the property, that survey, that the site plan is made, because you've got the parameters of where your property is, and then the site plan is just showing how far back and the dimensions and the elevation of the house on that property. So you buy the property and then you get the site plan, which has the legal description of the house on that property. And then when you transfer the house later on, it will have all the existing house shown on that property of what you're purchasing and what the existing setbacks are for that house. So I've already mentioned that, it's a plot plan. Provides a plan view of the property, and plan view is just a flat view. That's what we're dealing with in construction drawings, just flat, straight on views. That's very difficult because, when we're thinking about a house, we're thinking about three-dimensionally. BIM modeling, obviously, if we have a BIM model of the house, that makes it much more easy to visualize the house in its entirety. And you would see in the textbook that there's some 3D BIM sort of model illustrations of the Doncaster house so that you get a sense of how it's actually sitting on the property and the lot and how it rotates, etc. So the site plan will show you all of this type of information: location of property lines, setback location of the building from the property lines, contour lines, which I'll show you in a second, which is showing you the elevations at various points. And you may have existing contour lines for the existing slope of the lot, and then the new ones, or the graded contour lines, how you're going to adjust it to ensure that it slopes away from the building and fits the actual plat plan designed by the engineer if it's a multi-lot property. Elevation of the lands and buildings, and location of major building surfaces. Location of existing trees. So like in the city of Toronto or Vancouver or in other areas, there's a lot of protections that are being put into place to protect existing trees. And so trees over a certain size would be shown on the site plan, and usually you have to submit a separate landscape drawing which will show protection zones around the tree, how these trees are going to be protected during construction. Usually it's the drip line around the tree to ensure that that's not damaged in any way, proper rain flow so the tree gets water during the construction process, etc. Each jurisdiction is different in this aspect, so you have to be careful about the jurisdiction you're working in. I can't say that Calgary is like this and Vancouver is like this exactly, that they're the same, because the municipalities will have their own guidelines around this. And this gets into local bylaws and zoning requirements, etc. So there's not one you have to check within a particular lot. But certainly in major urban centers like Toronto, you have to look at, okay, so what are the sizes of the trees? You have to indicate them. They will send out an arborist to check before they'll assign the building permit to make sure that it's accurate and that the trees are going to be protected properly. And if you should cut down a tree that's over a certain size, then there's usually pretty large penalties. Some of these penalties are in the range of $15,000 to $20,000 per tree. And maybe you have, for a particular purpose, you have to cut down a tree. Well, then usually you have to pay the city a certain amount, and then that has to tie into your landscaping plan of how you're going to provide new trees on that particular lot. And any special features such as easements and right-of-ways. Pretty much every property has some sort of easement on it. An easement just means that maybe the cable company runs their cable wires through your property to get to other properties. Maybe along the back, usually where the properties line up, there's an easement for the telephone company and the cable company to run their wires to that. That means you can't say, oh, this is my property, I'm going to cut this wire because it bugs me. You can't, well, you could do that, but you're going to get yourself into a lot of hot water because they have an easement. And if they need to maintain it or do work on it, they have a right to get onto your property to do that work. Right-of-way is similar in the sense that there may be a right-of-way where somebody has to drive their vehicle through your property to get to their property. So it's a little bit more rare, say in urban centers, but you get into some more rural areas, it happens fairly frequently. So that means you can't all of a sudden put a big fence that prevents somebody from getting to their property if they have a legal right-of-way. Right-of-ways are always interesting. They make for interesting stories because there's all these sort of cases. Years back, I took a real estate course at York University, And the professor, I always remember, told me this story, or us this story, and it was how it was this farmland in Newmarket. And back then it was, there was still a lot more open land. There's still a fair bit of open land around Newmarket. And this farmer had this farm, and across the street, small street, the builder was building houses. And all of a sudden, while the builder was building houses, the farmer started to take his cows across to the river to drink water, or whatever it was. And the site super said, "Whoa, you can't cross here." And the farmer said, "My father crossed here, my grandfather crossed here, my great grandfather crossed here. I'm crossing here." So apparently, the farmer got their lawyer and sued the builder to say they have a legal right of way through that property to the river. And at the end of the day, the judge ruled that because of the history, I guess, I don't know, maybe he had pictures of his, during the 1880s of his great-great-grandfather going through with cows across the field. But anyway, the ruling was that he did have the right of way. So I think the builder ended up compensating him in some way that to prevent that, like to agreement for that. So you have to be careful. But usually rights of ways, that's a very uncommon issue. But usually rights of way, they're established. They're shown on the drawings. When you buy a property, your lawyer is going to go through it with you, say this is an easement, this is a right of way, just so you know, etc. Contour lines show, in this case, we've got existing, so natural grade, that would be the existing, and FG would be the finished grade. So you're going to adjust the grading. That means that at any point along this line, the actual elevation of the property is this much. So if it's saying 105 or 106, or let's just make sure I'm reading that right, 105, 104, 103, then any point along this line is at that elevation. So somewhere, half a block away, the elevation might be 100. All right, that means it's 100 meters above sea level. So 100 meters above mean sea level. If it's a benchmarked elevation, usually you find these little monuments on the side of buildings. And it'll be a registered elevation, and then a surveyor sort of adjusts the elevation from that point. And what that means is wherever that point is and it's at 100, you've gone up 3 meters. So now that just means that the grade is up 3 meters. And if you're an OLS, like an Ontario Land Surveyor, you can mark out the grading for the whole property and ensure that then it gets graded to those elevations. It also tells you how deep you're going to excavate for your footings. The footings have to be below the frost level, and they will have calculated that, and that tells you the elevation that you have to be for the depth of footing, and then the height of the walls and how much your first floor is going to be above the grade. Right? So there's all these little calculations that have to be developed to ensure that the grading is done properly. There may also be points and lines to show swales, so that the drainage, a swale is just sort of this indentation in the ground that just shows the direction of how the water is to flow along the ground. And the builder is going to excavate. If it's a bunch of houses, they're going to do a track excavation or a strip excavation to excavate for a whole bunch of houses at once. If it's one at a time, you're just excavating that one particular house. If it's a whole bunch of houses, you're doing a whole track of excavation, so that they're going to be now, and there'll be some final grading and things that'll have to be done. There's going to be some steps that'll have to be put in. But this will be excavated for the footings that will go in, that will support the houses. And the depth of this is all being determined by the site plans and the elevations, which are based on the engineered plat plan and those elevations, to make sure that the water in the whole subdivision has been calculated and the runoff has been calculated for that. And so there's all kinds of surveying equipment that is being utilized. Personally, I find surveying equipment has been, like a lot of technologies, has been upgrading itself on a yearly basis, and so it's improved by leaps and bounds. Somebody actually used to go out in fields and mark all these elevations very, very carefully everywhere as the work was being done, they can actually do all kinds of mapping now that will take all the positions and enter it into a software system without somebody having to go to each pole in each section. There's different methodologies that can be used. One, you can just drive a pickup truck around and it will take all of these coordinates through GPS systems, etc. So there's a lot of different ways that this methodology is being done and advanced. But in its simplest form, if you want to think about it, you can think about that you have a benchmark somewhere, and that would be that benchmark, like I said, 100 as an example, or maybe it's at 101.5 and it's on the side of a building, and that's what it is. That's been taken from the average mean sea level and coordinated through your city or town, and they have these benchmarks established, and that's all been worked out. Now you can reference from that so that you know what your elevation is, and that way everything can be calculated and laid out so that we ensure that the whole site has the proper slopes to it. So you take a site with a transit or a builder's level. Of course, we use much more like total station, etc. Technologies, and you get a site, but in its simplest form. This is 100. This is taking a site of 105. You spin this around, or 103, and you spin this around, and it's 105 actually. So there you go, 100, 105. And then you go to your area where you're at. This might say 3 meters down to where we want the finished floor to be, right? So then we know we're dropping from 105 down 3 meters, right? So this is going to be at the 102 meter point. That's our desired grade for that. We're just going to drop down and then we're there. We know what that should be. And then the same thing, you would drop down further to find out where your footing would go for the wall. And it would be listed what that depth is so that you know based on the height of the wall, it will come up to the right point. So in its simplest form, that's how these calculations are done. And of course, then the footings are put into place based on that. And usually what happens is you see these little pegs here. The builder or the developer, they're going to get a OLS, a registered land survey, or whatever your province is, whatever your area. So we call it OLS, Ontario Land Surveyor, and they're going to put pegs that will be based on the site plan to show how far set back the actual finished wall for the house is going to be. And then if you know the size of the footing, it's just measured from those pegs. So if, for example, if our footing is going to be 500 millimeters from outside edge to inside edge, and we know where the outside of our wall is, and let's say that our wall is 200 millimeters, right? So if we know that our wall is going to be 200 millimeters, then basically we know 500 millimeters minus 200 millimeters, that gives us 300 millimeters left. So there's going to be 150 millimeters on this side, and then we would have 200 millimeters for our footing, and then we'd have 150 millimeters left on the inside. So those pegs give us all the information we need to know so that all of these footings can be laid out. And the pegs, you can kind of see they're in the key places that everything could be referenced from them. And then you can lay out the footings, which are based on your site plan and based on your foundation plan for the actual house, so that your house is situated in the right location on the property that fits all of the zoning requirements and permit requirements, which we'll get into in lecture 1B. So the footings, as I said, they're wider than the foundation wall because they have to distribute the load that's being placed on them outwardly. And so they're going to be larger so that the bearing capacity of soil, it's easier for that to carry that load. So here's a site plan for one house. So this is the site plan for one house. Like all drawings, there'll typically be a legend that sort of identifies all the different elements for that particular house. And Here's actually a stormwater easement that goes between the two houses. The property line actually runs down along here, along there, up through here, and around this edge here, right? And here, this is a stormwater easement. So there's a storm drain that goes through here. There's another house over here. You don't see it. There's another site plan for it. If you look way back at that key plan that I talked about earlier, you'll see that there's, different lots going along here. So this nobody owns. This is actually ends up being a walkway into the ravine area because they would have put paths, bike paths, and different things along here. And it's also a natural area for for the community, but it also allows a lot of surface water to run off into that collection area through the tributary and the creeks and the rivers. So you can sort of see if you actually look at this. Actually, what I want you to do is just get a little bit familiar that all properties are not flat. They all have different slopes, different grades to them. And you have to figure out, well, okay, so what's going on? And look for those different grades and different slopes. If you're purchasing a property to develop, how many different slopes are there? How easy is it going to be to build on this lot? Some lots are pretty challenging because of the grade and what you'd have to do to actually construct on that particular lot. Others, they're not so challenging. This one's a little bit challenging because there's actually this embankment here, and you can sort of see in the actual legend by what it says this is. So it actually slopes off due to this embankment. And if I look over here, it says the embankment is a 3-to-1 maximum slope. So for every 3 feet, it would drop 1 feet, or for every 3 meters, it would drop 1 meter. So you can think about it that way. So like 10 feet, it would probably drop about 3 foot 3 inches roughly. So that's pretty steep. This is a little bit steep here. So there's this sort of runoff area here too that would hit this sort of path, I guess, and run towards the back. And you can also see there's a bunch of elevations that are given, spot elevations. So that's 110.32. So wherever the benchmark is, maybe the benchmark is down the street somewhere and it's at 105. Well, that means this has come up 5 meters from the distance to that benchmark. So you could figure out, based on that benchmark, what the elevation is supposed to be on the finished grade over here. And they actually give you a bunch of finished grades inside here, like the finished floor, top of basement wall, underside of footing. So that would be how deep we've got to excavate to. So that's 109.52. So we'd be coming down from this point here. And this is at the rear, under a footing at rear. So this part of the footing here is deeper because this area slopes so much. And we'll talk about this in another class, but you have to be below the frost level, which typically is at minimum 4 feet below grade. So, or 1220 below grade. So this here is giving you the various elevations. This helps us to going back a few slides so that the excavators know how deep they got to excavate to. You also see there's setbacks. So this determines how big the backyard's going to be, how far we're set from the side of another house. You notice that one setback on this particular house is 1.25 meters. On this one, it's 0.35 meters. So because of limiting distance requirements, how close we can be to another house, and the building code concerns itself with flame spread. And if one house catches fire, they don't want all the houses to catch fire. They want to slow it down, right? So there's a whole bunch of building code requirements in there. If it's a townhouse, it's got fire separation requirements and firewalls. If it's a single house next to another single house, we've got limiting distance requirements, which limits the size and the amount of area of windows depending on how far back the house is set back from the property. So one house is typically going to be more than 4 feet, while the other is going to be less than 4 feet. You can do it obviously more as a builder developer, but then that limits your footprint to build the houses. So that would mean you got to build smaller houses. Maybe that doesn't tie to highest and best use, providing the best value to the builder when they sell it. complicated. I know it all kind of, there's all these little things that kind of fit together. You're going to find that about construction. There's a lot of little things, and over time, you know what, your neural networks are going to start to join these little things up, and they're going to start to make a lot of sense. But in the beginning, it's like, what, I'm getting dizzy with all these things. So of course, every drawing will have a legend. These are always unique. You kind of got to look at them and read them. I don't memorize them typically. I recognize certain ones, but it also depends on what drawing you're looking at, because a street light here or a fire hydrant actually looks an awful lot like a light that you would see in a floor plan. So you got to put it in the context of what you're looking at, and always look at the legend first whenever you're looking at drawings. I thought it'd be worth it just to walk through this sort of example here. And with your textbooks, you have a copy of the Doncaster drawings. And the Doncaster drawings is kind of what I did. I photographed the house being built from start to finish, and the site plan and everything around it. So it makes it as a good talking point to give examples throughout this course. So I'll probably use that. I'm not trying to make this course about so much as reading drawings, but understanding visualization of what you're looking at and being able to then construct and contract that work out based on what you actually see is important, and it's a real skill set that you can develop over time. So keep that in mind. So this is a quick walkthrough. That's just the symbol. This, what we're talking about, catch basins in the street. The curb's not even put in yet. There will be a curb that will be put in around here. You can sort of see that double line. That will be a concrete curb, and these are the catch basins. So I'm standing at this point pretty much on top of the catch basins, and I'm looking out, and I'm looking down here. This is really where that stormwater easement is between the two properties, and so it's just flowing down there. This is the corner of the Doncaster house. You can see, remember I talked about phases, developer will build in phases. Well, if you go back to that original plat plan or that key map in the earlier slides, you'll see that this is showing filled with houses, and indeed now it is filled with houses. So they built in different phases out this subdivision. So this is at the side of the house right here, standing there, and you know what? There you can sort of see how the grade is starting to drop off. You can see that embankment over here. I'm going to see if I can get this, that I have a laser pointer there. That's a little bit better. And so that drops off down that point. And so that's sort of draining that way. It is sloping that way, and then it really kind of drains as it moves down that point. So you can, looking at it sideways, you see that embankment. And it said that it was approximately 1 meter on 3 meters. And I would say that's not far off, that 1 meter on 3 meters. It would go by the spot elevations, but it was just giving you an overall indication on that. Because this is probably, because that's the dining room, and then this is the family room back here. So that's probably a good 10 feet, and that's probably dropping a pretty good, close to a meter. So you get the idea how that actually works. There's at the corner of the property lines, the surveyors that we were talking about, they put in steel iron bars. Sometimes they're marked on the drawings, SIB, steel iron bars, to mark the corners of the lot. And other things that I mentioned, like services, that would be basically your water service shutoff valve. So it's going to be right there. It'll be in the driveway. There'll be a valve, then it'll be just asphalted around it, and that'll come out like flush with the driveway. And that's where you can turn on or shut off the water to the house. So say you had a flood inside and the water won't shut off, call the municipality, they'll come and they'll shut that off to that. So that's where that connection point is. It also here says like the stormwater and sanitary sewers for the street, where they are. So in a subdivision, you're going to have two sets of sewers. You're going to have one for stormwater and one for sanitary. The stormwater is taking, more clean water from a rainfall, and it's taking that into the drain system. It's going to go into the tributaries, into the rivers, and then it's going to go out into the lake. And of course, what they're trying to do more and more is have enough surface area that absorbs a lot of the rainwater so you don't have quite as much runoff. But that's how that's designed and engineered. And a sanitary runoff, that's different. That's basically the waste from your toilets and your sinks. And that's going to go into the sanitary system, sanitary sewer, and then it's going to go for wastewater treatment. So it's going to go to a wastewater treatment plant, and that's where it's treated so that it doesn't cause pollution and major environmental damage to our lakes. And so we want to reduce the amount of stormwater that gets mixed into that. In old cities like Toronto, as an example, you have the older streets, many of them, which have only one sewer. They have a combined sewer, both sanitary and stormwater. Unfortunately, that means when there's a big storm, all that water gets mixed in with the sanitary system, and the wastewater treatment plants don't have the capacity to treat that water. So they usually end up opening the gates and it goes straight into the lake. And that's usually why, for so many hours after there's a big storm, the city will say the beaches don't swim in them because the water's polluted, because there's certain bacteria that's built up that got in to the lakes till that kind of filters itself. So there's a lot of infrastructure, slow changes being made to existing streets in the cities to put in a combined system. So that's happening over time to separate out the systems. Anything that's newly built, I think it's over about the last 30, 40 years, is on separate systems. But anything before that, which is a big part of our infrastructure, is on single system unless it had been upgraded. So here's electrical transformer box, and that's used for electrical services. So those are that's for your hydro, and that's where your hydro would be run underground. In new subdivisions, typically your hydro lines are going to be run underground, not above ground. It's more protected against storms that way, so it's typically done underground. This is that stormwater easement that I mentioned. So I'm standing kind of in the drainage area there, and that drainage sewer from the stormwater sewer is taking all the water from the street, those catch basins I showed you earlier, and other ones around the neighborhood, and it's feeding it into this drain here, stormwater drain, and it's going out into the tributary, and that's going out down the tributary creek, and eventually goes into the lake. So it doesn't get clean. That's why you don't put oil and things like that into a street drain, because that means you're putting oil straight into the lakes. Because it doesn't get cleaned. Hydro. So if you want low insurance rate, pick a lot that you've got a fire hydrant on, and that can be very helpful. So that's your fire hydrant. There are other things that you may also see as well come up. This is a swale that I was mentioning. So this line with an arrow, that just means that the grading has been designed that the grade slopes. And if you remember, this is sloping here quite steeply. So this is where I'm standing somewhere around here now, taking the picture, and this is kind of looking this way. You can see that the water from both sides is running into the swale, and that's going to run here, and the tributary river is over here. So swales are designed to redirect the water away from homes. So that can be when the grading doesn't quite work, you can put in swales to try to redirect it different directions and make it work. Between the houses, you also want the water to, in this case, form a curvature and then run away. So you don't want the water to run right into the side of a house. You want this to be higher than that. And if you actually look at this, you can see that the grading, surface grading, is different. So like here it says 110.45, and then it says 110.3, and then it says 110.45. So that means this is the low point. It's 150 millimeters lower than here and here. So that means this is up 6 inches, and when this is finished, this should be up 6 inches. So the water goes down the middle, and then it runs that direction, right? So at the high point over here, we've got 112.4, and at the low point here, we've got 110.3. So that's going to slope, and any water that's gathering here is going to build up and run off. So you're always trying to design the grading that it runs away from the house, the surface water runs away as much as possible. You don't want the water, you want to try to limit the amount of water that's going down the foundation. We do have systems in place, weeping tile, to redirect that water away from the foundation too, but you don't want to risk Mother Nature, let's say, and have more water than necessary gathering around your foundation, because sooner or later it finds a way to get in. And so this is just looking at the rear of this particular house. And this particular house is a little bit different than the drawings you see for this, because you'll see that it offers a deeper basement window, and that's because of the advantage of the slope of the grade. So that, if it's sloped enough, you could actually have a basement walkout. There's indeed just down the street from here where there was more of a walkout, more of a slope in the backyard. There's a walkout that people can walk straight out of their basement, which means this deck is much higher in that case. In other cases, there is where the grade is just level and you've got a very small basement window like what's shown on your drawings. So it's very much depends on the lot. And by the way, one house in a subdivision, when we're talking about housing in small buildings, the same design is built multiple times. So like these Doncaster drawings in your book, they probably were built 40 or 50 times in that subdivision. They had probably about 6 different designs, and each one would have been built probably 40 times. And what they do is they change the design on the front of the house. And that change in design on the front of the house, the rest of the house is more or less the same. It makes it look different from the streetscape when you're walking along the street. It's actually what we call architectural control. Municipalities put certain controls on builders and developers. It's all over the map what they ask for, but different municipalities have architectural control. It's not that the builder can do whatever they want. They might say, no, you've got to have this mixture. We're after this kind of flavor of community here. They may dictate an architectural review where a separate third-party architect reviews to make sure that they're hitting the requirements that the city is after. So architectural control plays that kind of element in the design of the communities. Prior to that, before cities and municipalities started getting into architectural control, you know what, if I'm a builder, if I could build all the houses exactly the same, it would be so easy and so cheap to do. Henry Ford built the Model T based on that platform. You can have any color you want as long as it's black. Didn't want to change things for years, right? And they all were the same. They all looked the same. You can see some subdivisions in older parts of Toronto, even going back to the 1950s, 60s. So that was where we didn't really have too much architectural control. And I think you could drive home at night and go into the wrong driveway, go into the front door, and you'd be like, oh, it's the same house. So architectural control tries to mix it up, that it creates communities that have more uniqueness to them. Again, it's up to the municipalities. You might find that there's a municipality or town that you're from. That's not true. They're all the same. Well, then that municipality just didn't enact much in the way of architectural control that way. So that's pretty much lecture 1A that I wanted to go over with you. And again, make sure that you go through the chapter 5 of Understanding Construction Drawings and chapters 1 and 2 of the Canadian Wood Frame House Construction book, and that will help to really sort of solidify what we're talking about. You can get much deeper into your learning when you go through the textbooks in those particular areas. Okay, so I'm Tom Stevenson, and have a great day, and I'll see you in lecture 1B very